Now, if our inequality is absolute value of x plus 3 greater than or equal to 6, then what condition has to be satisfied by x plus 3? Well, first of all, if x plus 3 is greater than or equal to 6, now think about this for a second. If x plus 3 is greater than or equal to 6, then for sure the absolute value of x plus 3 will be greater than or equal to 6. So x plus 3 greater than or equal to 6 is sufficient to satisfy this condition. But it's not the only thing that can satisfy this condition, because if x plus 3 is less than or equal to negative 6, this also holds, because anything less than negative 6 is going to have an absolute value greater than 6. So that if x plus 3 is less than or equal to negative 6, you again satisfy the inequality, so that this condition is sufficient. So it could be either this or this. So what do we have? The inequality can be translated into two inequalities, x plus 3 greater than or equal to 6, or x plus 3 less than or equal to negative 6. X plus 3 greater than or equal to 6 gives you x greater than or equal to 3, and x plus 3 less than or equal to negative 6 gives you x less than or equal to negative 9, and that's very straightforward. As soon as you write these down, you can easily satisfy them. Well, what's that give us? That gives us the outside of an interval centered at negative 3, having extent 6 on this side and 6 on this side, extending 6 units this way and 6 units this way, because, again, from negative 3, 6 units this way just puts you at 3, and 6 units this way. Did I say negative 6 units? From negative 3, 6 units puts you at 3. From negative 3, 6 units in this direction puts you at negative 9. Now, again, in order to satisfy this inequality, where this absolute value is greater than or equal to 6, you're going to have this part of the number line. Okay, so this arrow represents this part of the solution. Okay, the part where x plus 3 is greater than or equal to 6. And over here, you have the part where x plus 3 is less than or equal to negative 6. So, we can generalize and say the absolute value of x minus h less than or equal to w is centered at h. Just like this is x plus 3, that's like x minus negative 3. So if h was negative 3, we would have absolute value of x plus 3. And that's less than or equal to w. Well, that would be like less than or equal to 6, not greater than or equal to 6. But this inequality then has center at x equals h, and extends w units to the right and w units to the left. So it goes from h minus w to h plus w. The interval then in interval notation would be h minus w, h plus w with the brackets. Then the inequality absolute value of x minus h greater than or equal to w would be just, I was going to say the complement of this interval, the outside of this interval, except for the fact that the intervals share the point at the end point, because I've got a greater than or equal here. I'm actually going to change that. I'm just going to make that greater than, and I'm going to change that solid dot to an open dot, just so I can say what I was about to say. Okay, now, if the absolute value of x minus h is either less than or equal to w or greater than w, any number is either less than or equal to w or greater than w, where w could be any number, same number both times, of course. So, the numbers that satisfy this inequality will be exactly the numbers that don't satisfy this one. The numbers that satisfy this one are the numbers between here and here, between w units to the left and w units to the right of h. So over here, that is going to be, the solution set to this is going to be everything that isn't here. So everything that isn't between here and here. W units to the left, W units to the right of H. So we're not going to include the endpoints of this interval since I don't have an equal sign on this greater than. And you see that what I have here is exactly everything that I don't have here. So when you have an inequality with a greater than, you basically have everything outside of some central interval. Now this can be interpreted in terms of distances, because the absolute value of the difference between two numbers is the distance between those numbers on the number line. So that to say that absolute value of x minus h is greater than w is to say that the distance between x and h is greater than w. So, well, here we have h. To get an x that satisfies this, we have to move to a distance greater than w, which would be out here, or on this side, out here. So, again, there's a geometric connection in terms of distance. So you can do this graphing, you can get this interval, you can get these solution sets in at least three ways: algebraically, in terms of a distance statement, or in terms of a translation.